Alright, and welcome to How to Graph Anything. So let's go ahead and start out with our very first example, example 1. What if I gave y'all something kind of funky? What if I gave y'all y is equal to 2x plus 3, I don't know, divided by 2. Okay, so what in the world would you want to do in order to graph this function? Well, what we're really going to focus on is just kind of a method on how to graph anything. So like if you don't know any of the specific rules of a function, what I would encourage you to do is this. I'd always encourage you to set x equal to, I'm going to call these smart numbers. Okay, x is equal to smart numbers. So what do I mean by that? Well, if I choose any arbitrary value of x to plug into this top thing, it will eventually be divided by 2. So in this case, I would want 2x plus 3 to equal any set of even numbers. By the way, that's the hashtag symbol, but it's actually called the number sign. All right, it's a shortcut for numbers. So as long as 2x plus 3 equals any even number, 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, as long as that's true, I will get a whole number. So how in the world can I kind of ensure that? Well, I could just say this. I could say something like, well, you know what, 2x plus 3, let's just set that equal to 2. Okay, so if I want that whole top thing to equal 2, well, I would subtract 3, I would subtract 3, and of course, that goes away. And now I've got 2x is equal to 2 minus 3, which is negative 1. I can divide both sides by 2, and x equals negative 1/2. Okay. So I know that if I use the value of negative 1/2, then that will make my top into an even number. Alright? The other cool thing that I know is that if that's true, well, it's also probably true that the positive version of that would equal an even number. And then the last thing that you can always try out is you can always try out x equaling 0. Alright? Because whenever x equals 0, just life tends to be easy. So here's what we're going to do. We're going to set x equal to negative 1/2, 0, and positive 1/2, and we're going to see what kind of outputs we get. So in this case, I can go, okay, you know what, we've got y is equal to 2 parentheses negative 1/2 plus 3 all divided by 2. Okay, and if I do this, well, 2 times negative 1/2 will be negative 1 plus 3 all divided by 2, which then becomes y is equal to negative 1 plus 3 is positive 2 divided by 2, and y equals 1. What this does is it gives us our very first point. When we know that x is equal to negative 1/2, y is equal to 1. So let me go ahead and write that up here. We have negative 1/2, comma, 1. There's our very first point. Now we'll go on to repeat this process several more times, and we're going to use these x values that we determined were intelligent x values. Okay, so next I can go, well, you know what if y is equal to 2 parentheses plus 3 all over 2, and here we're going to plug in this next x value of 0. Well, we know that 2 times 0 is 0, so this really just leaves us 3 divided by 2. Okay, so that's why 0 is so useful, because here when x is 0, our y value is 3 over 2. Okay, there's our next point. And lastly, let's go ahead and do this whole thing again, but with our final x value of 1/2. So I have 2x plus 3 all divided by 2, where my x value is going to be positive 1/2. Now I know that 2 times 1/2 is simply 1, so this gives us y is equal to 2, this gives us y is equal to 1 plus 3 divided by 2, and 1 plus 3 is 4 divided by 2, and 4 divided by 2 is 2. So we can say, okay, our next point is at 1/2, comma, 2. Now what's the rule? What are we really trying to do here? We're trying to just pick some arbitrary x values so that we can graph this function without knowing anything about it. So if I go to graph this, I know I can go, okay, negative 1/2, comma 1. Well, you know what? Here is negative 1. So halfway, Oh, and then we're going to go up a distance of positive 1. So if I go about here halfway, there's my point. There's my very first point. Okay, I know that 3 halves is really 1.5. So my very next point would be here at 0, 3 halves. And then I know that my very next point is positive 1 half, 2. So if I go to the right half a unit and then I go up 2, I have my point. Now the last thing to note is this is a linear function because the x has a value of 1. So we can just draw a straight line going through there, and there's our graph. You can pick any x values, and you can pick easy x values and you can pick difficult x values. But so long as you pick any 3 x values, you can find their outputs and you can graph the function. Let's try another example. Okay, here's example 2. Y is equal to 2x squared plus 3x plus 4. Now what I'm going to do here, because there's no fractions, I'm not really concerned with anything, I'm just going to say this. Let's let x equal negative 2, 0, and 2. Alright, I'm just picking these values at random. Okay, so we could say, okay, well, y is equal to 2 parentheses squared plus 3 parentheses plus 4. And let's plug in our very first value, negative 2, negative 2. And so we know this, y is equal to 2 times negative 2 squared is 4. 3 times negative 2 is negative 6 plus 4. Here I can say, well, you know what, 2 times 4 is 8. Negative 6 plus 4 is negative 2. And 8 minus 2 is 6. So our very first point is at negative 2, 6. Okay, now in our next x value, we know that our next x value is 0. Guys, look how easy 0 is going to be. Well, we know that 0 squared is 0. 0 times 2 is 0. It's gone. 3 times 0 is 0. And so really y is equal to 4. That's why I'd always encourage you to use x equals 0. So when x is 0, y is 4. Okay, let's go ahead and find our third point where x is a positive 2. And remember, where did I get these 3 x values? I just chose them at random. Alright guys, that's the key. You get to choose your x values at random if you just want to know how to graph something. And from here, let's plug in positive 2. Okay, so 2 squared is 4. 3 times 2 is 6. Here I know 2 times 4 is 8. And 6 plus 4 is 10. And so we're going to say 8 plus 10 is 18. And so we have 2, 18. Now this gives us enough information to graph this function just by using these 3 points chosen at random. So we kind of have a graph that's going to look something like this. If you go to the left 2 and then up 1, 2, 3, 4, 5, 6. Here is going to be our very first point, negative 2, 6. Our next point, 0, 4, 1, 2, 3, 4. It's right here. And lastly, our next value is at 2, 18. So you'll notice this one really skyrockets up quite a bit. So let's see. If that's 6, then 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. And so we know it's something like that. And we can go ahead and graph it. Okay. And there is going to be our rough sketch function. All right, let's go ahead and do one more example. Okay, let's take a look at example 3. Y is equal to the square root of x plus 4 minus 5. All right, well, let's really think about this. Okay, here we see that we have this x plus 4 is inside the square root. And what I would say to you is this. We always want our square roots to be perfect squares. So I know the square root of 0 is equal to 0. I know the square root of 1 is equal to 1. And I know the square root of 4 is equal to 2. Those are our 3 easiest numbers. So what that means is that 0, 1, and 4 are all inside the square root. We want to find x values where our inside the square root value, x plus 4, is equal to 0, where x plus 4 is equal to 1, and where x plus 4 is equal to 4. noticing I'm setting them equal to what's inside our perfect square roots. Now from there, this is pretty simple. Subtract 4 from both sides, and x is equal to negative 4. I subtract 4 from both sides, and x is equal to negative 3. I subtract 4 from both sides here, and x is equal to 0. So that's how I chose my 3 values here. Could you choose any arbitrary 3 values? Could you have chosen negative 1, 0, and 1? Yeah, you could have. Just your answers, your outputs would be a little bit gross. So here's negative 4, negative 3, and 0. These are our 3 x values that we are going to try out. Okay, so let's see what happens. I can say y is equal to the square root of my first x value, negative 4, plus 4 minus 5. Well, this is equal to the square root of 0 minus 5. And remember, the square root of 0 is just 0, so y is equal to negative 5. So I know I have one point at negative 4 comma negative 5. All right, well, let's go ahead and try this again. However, this time we'll go ahead and use our very next value. So our very next x value is negative 3. Okay, what happens? Y is equal to the square root of negative 3 plus 4 is going to be positive 1 minus 5. I know that the square root of 1 is 1 minus 5. And 1 minus 5 is negative 4. So I now have this point, negative 3, comma, negative 4. And let's go ahead and move on to our last little problem. Okay. Now we'll do the same thing. So I've got x plus 4 minus 5 on the outside, where now my x value is going to be 0. Okay, so what happens here? Well, 0 plus 4, we have the square root of 4 minus 5. And I know that the square root of 4 is 2 minus 5, and 2 minus 5 is negative 3. So I now have this point, 0 comma negative 3. Well, now that I have these 3 points, what I can do is I can go ahead and I can graph this function. So negative 4 comma negative 5, negative 4 comma negative 5, we just count to the left, 1, 2, 3, 4, 1, 2, 3, 4, 5, and we're right here. Okay? Okay, for negative 3 comma negative 4, I go to the left 3, I go down 4, and I have this point. And for 0 comma negative 3, I just go right here. And you'll notice that this graph looks like this. This is what we call a square root function. This is our square root function. And it'll look just like that. Alright guys, what's the big idea of this video? You can choose any x values to graph. And maybe you'll come out with ones that look kind of gross. But pick any 3 values that make sense to you, and then go ahead and graph the function. Alright, you know what? I'm going to do one final one just to really help you guys out. Okay, here's our 4th example. You can treat this one as kind of a bonus example, but check it out. Whenever we have a number being cubed, I know that it grows very, very quickly. So here's what we want to do. I know that negative 1 cubed is equal to negative 1. I know that 0 cubed is equal to 0. And I know that positive 1 cubed is equal to 1. So here's what we're saying here. We want to choose x values such that x minus 3 is equal to this negative 1, x minus 3 is equal to 0, and x minus 3 is equal to 1. Okay, and guys, in every case here, this is very easy. I just add 3 to both sides, and x is equal to negative 1 plus 3 is positive 2. I add 3 to both sides, and 0 plus 3, well, x is equal to 3. And here I add 3 to both sides, and 1 plus 3, well, x is equal to 4. So if we choose those 3 x values, if we evaluate this where x equals 2, 3, and 4, we should get some fairly simple numbers. And so let's go ahead and try this out. Okay, in our very first one, we'll do y is equal to 2 parentheses x minus 3 cubed plus 2, where our very first x value is 2. Okay, so we will get this. We'll get y is equal to 2, parentheses 2 minus 3 is negative 1 cubed plus 2. Y is now equal to 2 times negative 1 because negative 1 cubed is just negative 1. 2 times negative 1 is equal to negative 2 plus 2, which is equal to 0. So when x is equal to 2, our y value is equal to 0. And by the way, if you're not pausing these and finishing taking the notes before I erase it, you're not doing yourself any favors. You want to take every single note on the page. Okay, so now we have this. Y is equal to 2, parentheses, x minus 3 cubed plus 2, where our x value is positive 3. Okay, well this one looks pretty easy. 3 minus 3 is 0 cubed. But remember, 0 cubed is just 0, and 0 times 2 is 0. So really, it's just y is equal to 2. So now I have 3 comma 2. Okay, well, let's go ahead and look at our final number 4. Okay, well, here we have y is equal to 2 parentheses 4 minus 3 cubed plus 2. And from here, what I say, okay, well, y is equal to 2 parentheses 4 minus 3 is 1 cubed plus 2. And 1 cubed, well, we know that that's equal to 1. 2 times 1 plus 2. Well, what's 2 times 1? Well, y is equal to 2 plus 2. And so here we have, finally, when x is equal to 4, y is equal to 4 as well. Now, one thing to remember, that your cubic functions actually create kind of this weird curved graph. So for this one, whenever we have a cubic function, we just go, okay, you know what? Positive 2 comma 0 is right there. 3 comma 2 is right there. And let's see, 4 comma 4 is right there. And our cubic graph looks something like that. Alright guys, good luck on this section. Remember, you get to pick any 3 x values, and then that is going to generate any sort of graph. You get to kind of test it out, play with the numbers, okay? Alright guys, I'll see y'all in our next video.